This video is on wireless communication considerations for embedded systems. There are a variety of communication technologies available for embedded and specialized systems. First, we have 5G, which refers to the fifth generation of mobile networks. It is a new global wireless standard made to connect virtually everyone and everything. I'd like to note that not all 5G are the same. There's mmWave, low band, and mid-band 5G. But 5G is the first wireless standard to take advantage of the mmWave. So we will focus on the mmWave. Waves that operate at lower frequency have longer wavelengths. So modulations happen at a slower pace, meaning lower bandwidth. Frequencies at higher wavelength does the opposite, meaning it talks fast and results in higher bandwidth. The mmWave is the latest and greatest because it uses higher radio frequencies that were not used before. This means that the millimeter waves are not as cluttered compared to the older generations, which allows it to carry more information at a faster rate. However, higher wavelengths tend to get more distorted and are easily blocked by objects. This is why 5G has adapted beam switching, where if the signal quality becomes unreliable, it jumps over to a new frequency band until a more reliable and faster connection is available. Another biggest downside regarding mmWave is the distance. This is why for it to be effective, there will need to be multiple input and output antennas to boost signal and capacity across the wireless network. This type of communication technology will enhance things like machine learning enabled automation. mmWave will provide the quickness needed for machine learning and artificial intelligence to deliver automation capability. The 5G architectures will be software-defined and can create software-defined sub-network constructs known as the network slices. And these slices enable network admins to dictate network functionality based on users and devices. Next, we have narrowband data communication, which uses only a small frequency band to transmit data with high efficiency, making it the perfect option for any application which needs a reliable and low power due to its minimal amount of bandwidth usage. It is used in a lot of wireless applications like radio frequency identification and commercial vehicle remote keyless entry. It's highly applicable in sensors as well for SCADA system. Then we have baseband, which is a radio frequency signal that occupies the lowest range of frequency spectrum. In baseband, frequency is not shifted to some other frequency band by means of modulating. A baseband unit, BBU, is a telecommunication network device used to process baseband signals and is required to convert analog into binaries. Let's talk about SIM cards, subscriber identity module cards. This can be a tiny removable smart card for mobile phones that has information used to authenticate and identify subscribers on the network. Treat it like a plane ticket with government issued card. There's also eSIM, embedded SIM, which is a programmable SIM card that is embedded directly into a device. SIM cards can be used for numerous systems and not only phones, from drones to vehicles. It's easy to use and eSIM can be rewritable. Lastly, we have Zigbee, which is simply a wireless standard. It is a IEEE 802.15.4 based specification for a suite of high-level communication protocols that is used to create personal area networks with small low-power digital radios. It operates on 2.4 GHz, which is the same frequency band as Wi-Fi and Bluetooth. Zigbee is slower than Wi-Fi, but only tiny amounts of data needs to be transferred for smart devices, so it doesn't really matter. This is an effective choice because it is a low latency wireless mesh network which requires less power and saves cost. It's mainly used in wireless control and monitoring applications. Zigbee standards allow instructions for smart devices and can communicate with multiple devices at once, and it's great for Internet of Things applications.